consultancy specialising in temporary works and demolition engineering. That is what we do. That is all we do. Got a couple of little projects there. Churchill Way flyover demolition, top right, Centre Point Tower, and then A13 bridge demolition, Clark Demolition. So that's enough of the sales spiel. We'll get on to the bit you're all here for. So let's start off with what is demolition. So demolition is the act of taking a structure apart. That can be full demolition, that can be partial demolition. There's really two key ways to achieve demolition: deliberate collapse or progressive demolition methods. Deliberate collapse is blowdowns and pull downs of structures. These are the big impressive ones where a structure was standing and then next thing we know it wasn't. Then there's progressive side. Now the progressive demolition can be used for full or partial demolition. So if you're doing refurbishment works, that would be partial demolition. If you're taking the whole structure down, that's full demolition. Methodologies and techniques include top down, which is, as it sounds, you start at the top of the structure and work your way down to the ground or even below ground. High reach, which is a large excavator equipped to reach up high and then out horizontally, demolishes the structure. Deconstruction and dismantling, so that's taking things apart in the reverse of the way in which they were built, though you might use hot or cold cutting techniques to cut the structure into parts, or you can use a combination of the above. It's fairly common to use a combination of methods. So for instance, with top-down demolition, you might well break out slabs using a brock or a small excavator, and then you might use dismantling techniques to take apart the steel frame or even the concrete frame of the structure. So it's not unusual for a combination of techniques to be used. So this is kind of what people think demolition is. People still have this image, though perhaps less so, of dirty work, uncontrolled, letting a man free with a wrecking ball. So I just dug up this little video on the internet here of a wrecking ball being used in New York. Not sure what time, but I'm guessing quite a long time ago, probably the 70s, early 80s. Using a wrecking ball to demolish a structure. Quite a quick method, but not necessarily that controlled, and relies purely on the skill of the operator. The other thing people think of with demolition is wrecking balls. Not wrecking balls, sorry, is Fred Dibner taking down chimneys. I think many of us when we were younger saw Fred Dibner on telly taking down masonry chimneys and the like, and that's kind of associated still with demolition. In fact, some of our clients actually worked with Fred Dibner when he was around and live and kicking still, which is interesting. If you've got time to kill, there's plenty of videos on YouTube of wrecking balls, but as you can see there, they're not messing around in the speed of the time it takes to demolish a structure. Now in reality, demolition is actually quite a high-tech and well-developed industry within the UK. So starting on the top left there, I'm going to move slowly with the mouse because I know it's quite laggy. On the other end of these webinars, you've got for Coleman and Company at Birmingham New Street, a specially developed excavator developed in conjunction with Coleman's and JCB. So this machine was actually remotely operated, or it could be remotely operated, and was a hybrid between a 20 tonner and a 15 tonner, and then running a much larger attachment. And it's developed specifically to allow certain beams to be demolished at Birmingham New Street Station. And you've got Centre Point House or Centre Point Tower here, which is another technically complex demolition scheme right at the top of the tower, combining, I think it was the top 3 or 4, or working on the top 3 or 4 floor levels. Was it 3 or 4, Josh?
It's the top 4 levels of Centre Point that had a facade retention scheme around the outside, and the top 4 levels, including partial roof, were totally removed. So on that picture on the left hand side, you can see like the floor to ceiling height. There would have been, I think, 2 floors within there, because it was a plant room to service the tower when it was used, when it had boiler tanks and things up there. But then it's been turned into some fancy pants apartments at the top of Centre Point Tower. So you need plenty of room for those, don't you?
You do. So that was quite a complex job right at the top of that tower. You can kind of imagine yourselves the structural implications of taking out that much of a structure at that height, including maintaining the facade, that listed facade, I believe. Then in the middle there, you've got the latest high reach. I think it's still the biggest in the country, though that changes. This is DSM's machine, and it is an absolute beast. If you stand next to it, your head comes up to about track level. I think it weighs best part 220 tons. Can reach 70 meters in the air and about 15, 16 meters out and run a big tool. You're talking multi-million-pound investment by demolition companies to run a plant like this, but nothing beats it when it comes to doing a multi-story tower block, as you can see there. Then you've got, again, Coleman and Company, development of specialist lifting equipment and cranes for taking down gas holders. You got works we did at Manor Park with Hockteeth and Kilnbridge, taking out structures over the railway line. All of these things are going on a regular basis, and they form part of demolition and the temporary works required for demolition. So when we talk about temporary works, we always come back to BS 5975. The latest version is 2019, covers design and procedural control of temporary works. I'm not going to read this clause out because it's very, very wordy and doesn't exactly roll off the tongue. Interestingly, the latest version, as in 2019, specifically mentions demolition in a number of places, including just underneath the introductory paragraph. If you compare that to the old BS 5975 2008, demolition wasn't even mentioned once within that document. And trust me, I double checked this last night, searching for keywords to see if demolition or demolish was in there, and it's not in there at all. Whereas in the introductory section of 5975, it specifically identifies demolition in 1, 2, 3, 4, 5 places, and I've gone 1, 2, 5 there, 5 places. So that's quite a step change between 2019 and the 2008 version. So let's have a look at what that actually means. What do each of these clauses mean? So starting with clause A, supporting or protecting either an existing structure or the permanent work during construction, modification or demolition. So a good example of that, protection of a railway line during demolition. This is of a job in Newport, I think. Yes, it was Newport. Pair of bridges that were taken out. This was back working for Foreshore, and then actually it was for Carillion. So that shows how long ago that was, but it's quite a good example of track protection there. Then you've got this other point here, supporting or protecting. So this is a scheme did in London with John F. Hunt. So this is a facade retention for the top 2 stories. And then we were taking out the core of the structure as well. So we had to put in temporary stability bracing. So that's a very good example there of temporary works to maintain the stability of the permanent works, in this case during refurbishment, in this case here during demolition or complete demolition. So the next one is provision of stability to the permanent structure during construction, pre-weakening or demolition, e.g. propping, shoring, facade retention. So again, this is Centre Point Tower for John F. Hunt. Again, you can see some of the temporary works that was put in place to maintain the stability of the top 4 stories of that structure whilst the demolition was undertaken, and indeed the reconstruction of the new floors. And again, similarly here, we've got a facade retention scheme in Leeds. Kind of speaks for itself. It's holding the facade up while the internals of the structure are demolished. And there's another little picture of inside Centre Point Tower, again showing you how empty and open the structure became. So then we look at the next clause, providing measures to control noise, dust, debris, fume, air quality, groundwater, or any site discharges during construction or demolition, e.g. screens, bunds, dewatering, demolition debris. So a good example of that is a demolition curtain here. So that's basically a big rubber curtain. Generally, it can be made up of any number of different items, being suspended from a crane whilst the high reach, so that's the high reach we saw at the beginning, is used to take down a structure. Then you've got the other simple side is scaffolding. Regularly build scaffolds around structures to protect, to stop debris getting out whilst the demolition is being undertaken. And then the other side is, I think I mentioned this in the presentation last week, is that AR Demolition have developed a scheme or a methodology for protecting, more robustly protecting the public and anyone outside the site from anything getting out of the site. So here you've got a big steel tower clad with, I'm not sure if it's plywood or what. We didn't actually design this. I just happened to see a presentation about it and went and nicked this off AR Demolition's website. I hope they don't mind. I know there's a few, well, there was last week a few watching, but I'm sure they'll tell me off if they mind. The last one is facilitating testing. So e.g. pressure testing pipes, pile testing, pre-demolition floor load, capacity testing. So it's fairly common now that structure is tested to establish the capacity. So this is usually in addition to some sort of structural analysis. We then undertake physical testing. So in this case here, we've got a jack and we're using a couple of floors above to resist the jacking load that we're applying. And then we're measuring the deflection underneath the slab here. Obviously you don't stand underneath it here or on top of it when you're actually jacking it. The deflection monitoring system has a remote reading, so you can stand well out of the way. And similarly, you don't have to stand on the slab when you're doing the testing. It's just Josh likes to show people on his drawings. So that's what that is. So when we do testing, we generally do testing for bending, and we also do a check for shear. The reason we do a check for shear is because shear to us is the critical failure. There's not normally a great deal of warning of an impending shear failure, and it's useful to verify that the capacities we're assuming or calculated actually match the reality of what we're achieving. So designing and checking temporary works. Now, the webinar last week, this document was actually referred to by one of the people. I can't remember who it was, to be honest. Now, this is the NFDC's document, guidance document on temporary works for demolition, which is freely available on their website, and it makes a good background reading, written by Tim Lohman of Wentworth House and Holly Price, who are both quite well known in demolition circles and certainly speak with authority. Within that document, they've identified how they see, or how the NFDC sees risk within temporary works, and gives you an idea of when it needs to be Cat 1, when it needs to be Cat 2, and when it needs to be Cat 3 checked. And just for the benefit of those of you who maybe don't deal with temporary works regularly, Cat 1 means someone in the same design team can check it with reference to the calculations, if required, if they want to. Cat 2 means someone within the same business, though not within the same design team, can undertake the check, and they must not reference or see the original calculations. And a Cat 3 is similar. However, the check is undertaken by a completely independent company. Now, generally speaking, the way we deal with Cat 2 checking is if the Chelmsford office designs it, the Josh's office in the Midlands will check it, or the Scottish office will check it, and that maintains that independence between design teams and ensures that you're getting a proper Cat 2 check. I'm not going to read all those out. You can read them yourselves. But then we talk about the Cat 3 check here. So they consider that facade retention schemes close to public areas should be Cat 3'd. That makes sense to me. Bridge demolition, again, generally speaking, a Cat 3 check may be appropriate, though depends on the bridge, I would suggest, though who am I to argue with industry guidance. Modification to an existing structure or partial demolition is a very, or can be a very high risk area. You really need to understand the structure. I'm not going to talk about excavations because it's not particularly relevant to the demolition side of things. Demolition plant operating on a suspended slab where more than the immediate bay floor is vulnerable. Again, I don't disagree with that. Use of existing structures as anchorage for cutting away and lowering large steel or concrete cantilever sections Again, that makes sense to have a Cat 3 check on anything involving that. And pre-weakening and collapse schemes for explosive demolition where the surrounding clear area is less than 1 times building height in all directions. Again, it makes sense to have a Cat 3 check in those situations. But again, it's always important to remember that this is guidance, and it's down to the site team, the TWC, and the project managers on the site to decide whether it warrants a Cat 3 check. Something that may be simple in a greenfield site can become very, very vital and require a Cat 3 check on a city site, or even a rail site, or within a live refinery complex or similar. It's the onus is on people to apply their competence to decide what level of checking is required, and speak to your designers if you want a little bit more, if you want to discuss it with someone further. All right, so now we're going to go on. We're going to talk about specific items of temporary works for demolition. Now, this is a project that we completed for DSM at White Hart Lane. So for any of you who are not fans of Tottenham, we actually demolished Tottenham, or DSM did. We did the engineering behind it. I can't claim that this design is mine. It's my father's, and it's a nice, clear set of drawings that shows the level of engineering and the thought that goes into planning a pull down or a blow down. It has to be engineered as anything else is engineered. You can see here we've gone so far as showing where to sit the excavators, where they're going to pull from, the angles they're going to pull from, the force we've estimated. And then we've even gone as far as, well, what happens if this thing gets caught up when it's being pulled down? What do we do? How do we actually get this down if it doesn't pull as we've planned? So it's all there, it's all been thought out. And that hasn't loaded. I'm not sure what happened to that page there. I deleted that page. So we'll skip straight onto the video. So this is the reality of it. That's from the Demolition News website and their YouTube page. You can find lots of nice videos on there. Hopefully you didn't have your volume up too loud when you played that and you just deafened yourself like I almost did. What you can't see there is half of the site was sitting in the newly constructed seating directly behind the machines here watching that. So there was quite a lot of spectators there if it hadn't gone quite as planned. But for context, that's about 110 meters long, 200 and something tons that was dropped. And it was by far the safest methodology for doing that. And it was completed successfully. For some reason that picture isn't loading. Oh, there we go. It is loading. I had to press my key again. So that puts the size of that truss into context there. It was a beast. The alternative was to use a pair of cranes to lift down, but that brought with it its own risks. A tandem lift of a structure that size, plus the fact that the cranes they needed were on the site and were being used for the construction of the new stand. And once you'd picked it up, there wasn't really the room to put it down again, given where the cranes needed to stand. So all in all, it was the correct solution to taking that truss down. Pre-weakening. So pre-weakening of a structure, you undertake that prior to a pull down or a blow down of a structure. It is vitally important that people who are involved with pre-weakening of a structure know what they're doing. That goes from the designers right through to the people actually on site pre-cutting the structure. Workmanship can be vital. The setting out of the cuts can be vital as well. Checking, the site team need to make sure that the correct pieces are cut and correcting the cut in the right place at the right time, there's an awful lot to go wrong. You're physically going into a structure and weakening it so it can be pulled down or blown down with explosive. It really is about as high risk as it gets. The form of cut needs to be carefully considered. You need to make sure you're doing the absolute minimum necessary pre-weakening, and that the final release cuts are only undertaken once the structure is ready to be pulled down. Calculations should be undertaken to justify the design, and those calculations must consider the age of the structure and the material properties. It's important to see that clear, concise drawings are produced, by which I mean every column is identified that is to be cut, and it's clearly labelled which form of cut is to be undertaken. Historically, we've seen some very poor packages come in for checking that the drawings just aren't clear, the methodology isn't clear or clearly communicated. It's not a place to be complacent. It's really not. The mechanism used to collapse the structure should be as simple as possible, and you should consider sensitivity analysis. So what I mean by that is, if you're pulling down a structure or blowing down a structure that has a significant load on it or a significant dead load, a sensitivity analysis as to whether you've got the dead load and assessed properly. Have you gone too high or have you gone too low? If you go too high, you can overly increase the stability of the structure. If you've gone too low, you can do the opposite. It's careful to look at. You have to look at it holistically and make sure you know what you're doing effectively. Working platforms. Now, working platforms for construction, quite well understood. Piling platforms for cranes, for concrete pumps, everything else is generally designed properly. Working platforms for demolition, maybe not quite so heavily pushed, I would suggest. I suppose the advantage you have is there's generally a lot of rubble around on a demolition site, and they can compact and form a platform to suit. However, some of these machines now are 200 plus tons, and you can get significant bearing pressures. You'll also find it very difficult to get track pressures from the manufacturer, in our experience. So you often have to work from first principles, so start from the COG of the components and working out how the bearing pressures will be affected. So it can be quite drawn out. Often you'll find the worst case is when you're lifting the arm up, i.e. when it's horizontal on the ground to getting it to vertical. That can induce some significant loadings, bearing pressures. LPS structures, so press play. This is Edgbaston, again from Demolition News. This is DSM. I'm going to deafen you again. Trying to deafen you all again. LPS structures, so large panel system. LPS structures were originally built in the 60s, 60s really. They are essentially gravity structures. Many of you will be aware of the Ronan Point disaster, which was an LPS structure where a gas leak and a subsequent gas explosion blew out one of the wall panels and led to something like 20 stories collapsing. These structures are susceptible to collapse and can require significant temporary works and engineering to maintain the stability during the demolition. I know this one, Edgbaston, had definitely had its challenges, but it was successfully completed by DSM in a very credible manner. But they are another one to be aware of. You'll find that a lot of LPS structures were stiffened, or not stiffened, were strengthened in the course of their lives, but many of them weren't. You'll also find structures that were supposed to have been strengthened. When you get to site, they haven't been. We've been involved in quite a lot of these structures, from that one at Edgbaston through to one that Josh is currently on in Coventry. They definitely have their quirks and their potential pitfalls for those who are inexperienced. And then probably one of my favourite things to do, which is bridge demolition sequences. Bridge bridges can come from very, very simple single span structures that you can take apart without any real engineering input, through to large scale post tension structures, and the temporary works involved between them varies considerably. So this is a video from Filton Bank in Bristol, where we had to take down a historic viaduct, 3-span bridge, and we could only access the structure from one side. The railway had to remain live throughout, so you'll see intermittently in the background, you'll see a train passing, and you'll see the sequence that was undertaken and the propping that was put in place, the temporary propping that was installed to maintain the stability of the structure and still allow us to take it out as we worked our way along. I like this one because the video's been quite nicely done, and I think the music fits it. But again, shows some of the temporary works that are involved. If you go to this site now, you'll find there's actually now a new embankment there, and then a single span bridge. It's changed the area significantly, and it was part of the Filton Bank 4 tracking project. We were working for Sam Evans, who were in turn working for I think Taylor Woodrow. It might have been Vincy Taylor Woodrow, for Network Rail, and it was successfully completed again over an August bank holiday a couple of years ago now, 2018 maybe. Can't really remember. Do so many bridges, they all start to blend into one. The last section they're doing there, that was actually undertaken in the possession one night, but the rest of it was all done with a live railway line, and it wasn't really that far away from the live rail at all. So there's quite a lot of interest on the demolition sequence and methodology from Network Rail to allow us to complete the works. There you go, it's Vincy, not Taylor Woodrow. If you want to know more, I can suggest no better starting point than the Temporary Works Forum website. BS 5975 2019 has an awful lot of information in it. For demolition specific, you've got the National Federation of Demolition Contractors. They produce a number of guidance documents here, one of which I referred to earlier in the presentation. And the Institute of Demolition Engineers, again, similarly, that is the kind of go-to place for demolition engineers. And there's also Temporary Works Principles of Design and Construction, and there's also the Temporary Works Toolkit. I've written one on demolition, though there's another 20 odd that cover various different temporary works items. I'm not sure if it's free anymore. I'm pretty sure you have to pay for those now on the iStructE website, but they are there and they are available if you want to learn more. So just have a